Alrighty, so we are getting ready to start the pinnacle project of your organic laboratory careers. As I think I probably told you guys at some point, I think an overall consensus has been in the past that students find this the most challenging and the most fun at the same time, because you know, there's a lot of independence at any given time. You're deciding, what should I do now? Help figure out what this unknown is. All right, so let me explain the rules of the game. Rules. Oh, okay. Right. You were given two unknown organic compounds. We'll call those UNCs. Right? They are roughly pure, and they're oils or solids. Okay? Before I forget, did I press the button? Are you out there? I did. Okay, good. Normally I do this. Sorry. Okay. Before I forget about this, you are going to take a melting point or a boiling point, but you're only going to take one. So if it's a liquid at room temperature, you're going to take a boiling point, right? And I'll teach you how to do a boiling point. Probably not this week. I want to get going on getting the lab started and everything. But next week I'll teach you how to do a boiling point. But if it's a solid at room temperature, you end up with a little solid, then you're going to do a melting point. Okay. All right. Each UNC contains only one, students sometimes miss this point, of the main functional groups. Okay. Main FG. Okay. So what are those functional groups? You guys know them. You just put them on their quiz and crushed it. It's ketone. Or could be an aldehyde. Okay. Or could be an ester. Okay. Could be a carboxylic acid. Could be an amine. Could be an alcohol, or could be a phenol, which technically is a type alcohol, but nonetheless. This means there are some that are non-phenolic alcohols, or you could have phenolic alcohols. So that's why we come up with 7 possibilities. Okay? And again, I reiterate, you can only have one of those. All right? As it turns out, I think it gives students a little bit of comfort and relief. To get a good grade on this project and on this report and everything like that, it's not that dependent on did I get the right product. Okay? It's dependent more on you know, did I include everything? It's amazing how much of schooling is. Did I do all the stuff I'm supposed to do and hand in, all the stuff I'm supposed to hand in? That gets you a long way. 70% of life is showing up. Also depends a lot, like did I, when I was analyzing my NMR and assigning signals, did I make reasonable assignments? Okay? There is a component of the grade that is, you know, how close did I get to the real thing, but it's not a super major product. Now, if you have the right component, those other things have a little bit better chance of being, you know, your assignments in NMR and stuff like that have a better chance of being close and everything. But you don't have to get this thing dead on to get a good grade on this. Okay? This will shock people, but almost all students get at least one of them perfect, and many students get both of them perfect. Okay? So it's certainly not an undoable task. But that little component that how did I do on getting pretty close to my thing, if you put two of these functional groups on your structure, I think it's a ketone and an amine that's automatic ding, right? Because you know it's not remembering that. You can only have one of these. Okay? But then we have a second group of subsidiary functional groups. My notes say subsidiary, but is that what it says in the reading? Last night I was like, they call it subsidiary? Okay, cool. For some reason I got paranoid last night. I thought, oh, maybe they use a different word or something in the notes. Okay. So, C, each unk may or may not contain one or more subsidiary functional group, FG. Okay. What are the subsidiary functional groups that are possible? That's halide, nitro group, alkene, alkyne, ether, aromatic. Okay. All right. Okay. So how are we going to figure this out? There's a few different ways. You're going to do some initial physical tests. What does it look like? You know, I mean, those things are fairly consistent. Camphor, you know, is a white crystalline solid. You know, different. I'm struggling to think off the top of my head. Eugenol is almost always a clear, slightly yellowish oil. So that's good information. You want to note that, stuff like that. Smell. Some of these, by the way, are very stinky. So you want to do the wafting thing. You want to keep it in a beaker so that you don't accidentally spill it and ruin this lab for the next 4 weeks. That's happened. Okay. And some of them, if you've got a super stinker, you know, maybe try to open it in the hood and stuff like that. Be a good friend to your lab mates and stuff. The other thing are pipettes. If you put it into a stinker, okay. In general, if you put a pipette into your unknown, or you put a spatula into your unknown, I'd like you to keep a beaker by your desk and grab that ethanol that's right in front of you there and give it a little squirt. Give the pipette a squirt before it goes in there. That's another thing we've had. We've had people put it in a really stinky one, then they put the pipette in there, and then the room is ruined for a long time, and other professors get very mad at me. Okay. All right, so the initial physical tests, all right? And this initial physical test can sometimes give you a little bit of an idea of what functional group it might be. Amines have sort of a pungent, fishy smell. Esters have kind of a sweet smell. Alcohols also have a sweet smell. So forth and so on. Okay? Carboxylic acids often have sort of a noxious smell. Body odor is partially butyric acid, which is carboxylic acid. Okay? So if you have a male person that you live with and they're getting a little bit right, you say, hey, the butyric acid's killing you, bro. Okay? Address that. We're going to do qualitative tests. And qualitative tests are ones that, they give some sort of reaction, some sort of physical indication that you have that particular unknown. Okay. And you guys have learned those, you studied those for today, right? The 2,4-DMP test is for aldehydes and ketones, so forth and so on. So that'll give you good initial information on what your functional loop is. Now, it's written in here. I always like to shoot from the hip and then put this on the board. But the very first thing you're going to do after your physical test and stuff is you're going to do an aqueous solubility test. Okay? And the aqueous solubility test is very important. I now suggest that over the course of these weeks, you do it at least 3 times on each of them. They can really sort of make and break you. Okay? Do it just the way it's described in the book, but don't change that too much. All right? And if it's not soluble in there, okay, then you want to heat it a bit. All right? Definitely want to heat it and stir it. There are things that, sugar is extremely soluble in water. Okay, but if you dump it into your coffee and you don't stir it and heat it, it's just going to sit down at the bottom, even though it's highly soluble, right, in water. Okay, so some things do really, they will eventually dissolve, but it's going to take hours unless you stir it. Okay. A nice little trick, by the way, if you have, let's see if I can just do it. Sometimes. Alright, we'll pretend this is. Sometimes if you have an oil and you're like, the meniscus can kind of make sort of a funny diffraction, and so it looks like, wait, is that a meniscus kind of weird visual thing, or is there oil sitting on top of this water? Okay? Nice thing you can do is go ahead and hold the test tube at the top and give it a little flick. Okay? If it does sort of a lava lamp where you get little oil droplets or Italian dressing going down into the water, that's real oil. That's not an optical illusion like a meniscus thing. That make sense? Okay. All right, so, and you don't want to do all of the aqueous solubilities. There's a flow chart on page 462. I think it's 462. Yeah, 462. There's a flow chart on there. Okay, it starts with water. If it's soluble in water, then it's a low molecular weight compound. Okay, and then you're going to use pH paper and litmus paper to decide, is it a low molecular weight carboxylic acid, or is it a low molecular weight amine? Okay, all right. If it's not soluble in water, then you're going to move on to concentrated hydroxide. Okay? If it's soluble in concentrated hydroxide, at that point, you have very good indication that it's either a carboxylic acid or it's a phenol. Okay? It wasn't soluble in water, but once you put it in hydroxide, it was soluble, which means it got deprotonated. It became anionic, and that's why it likes to be in water now. Well, the only 2 things that are possible out of those groups that can be deprotonated by hydroxide are phenols and carboxylic acids. Okay? And then you'll try. So maybe it funnels you all the way to a phenol. Okay? Then you're working on the premise that you have a phenol. You only want to do qualitative tests that are appropriate for the phenol. Don't do a nitrous acid test on something that you think is a phenol. Nitrous acid test is for amines, okay? And if you do, students somehow, it often happens, students get a little bit worried, I better do every test on every unknown, and that actually can distract you more than it helps you, okay? Sometimes if it's a really inappropriate test for your particular functional group, it can give kind of confusing results, actually. Now, you might get a precipitate, but for the wrong reason. It might get an acid-base precipitate or something like that. Okay, does that make sense? All right. So the qualitative tests will give you good indication of what your functional group is, your main functional group, and your subsidiary group. You do not need to do all the functional group tests, all the qualitative tests for these things. Again, do the ones, right? But for the subsidiary groups, you should do all of them. Okay, there's going to end up being 4 ones that test for we have a test for halides, we have a test for alkenes and alkynes and aromatics. We don't really have a test for ether, and we don't have a test for nitro, or we don't do them. I don't think there's a test for ether. Yeah.
So over the next 4 weeks, how many of the unknowns are we each going to do?
You each get 2.
Okay.
Yeah. Yeah. You get 2 unknowns, and you use the same unknown every week. I mean, they're numbered, and so you'll use your number. Yeah.
Sorry, off topic a little bit. Are we going to take the melting point of our?
Yes.
Okay.
Yeah. You got to take your melting point of your nitromethylbenzol. Right? Okay. And then you're going to take a proton NMR. You're going to take a C13 NMR, and you're going to take an IR. Okay. IR helps you give confirmation on functional group, right? That's sort of the point of IR. It's got certain absorptions that you expect to see for certain functional groups. Proton NMR and C13 NMR give you some indirect information about functional group as well, right? A ketone has a very distinctive carbon signal in the carbon NMR for ketones, right up around 200. Okay? So that's something you really want to see if you think you have a ketone or an aldehyde. They're in the same region. A little bit shifted, but same basic region. Okay? So these things all sort of feed into each other. NMR and C13 will also give you what does that carbon framework look like. The qualitative tests don't give you very much information in terms of that. Like how is this thing assembled? What's right next to each other? Oh, I've got a singlet around 0.9 that integrates for 3. Well, that's probably a methyl group without any neighbors. It's a singlet, so it doesn't got any neighbors. Anything around 0.9 ppm that integrates for 3 is probably a methyl group. Okay. Or if I had a triplet near 0.9 that integrated for 3, that's probably a methyl group that has a CH2 as a neighbor. Okay. All right, make sense? Okay. All right. Also, melting point and boiling point don't give you a lot of information, a lot of general information, but they do give you great information in terms of confirmation. Oh, I think this is butyric acid. Well, here is butyric acid's melting point, or I forget what it is, a room temperature boiling point maybe. So, it ought to be close to what the literature boiling point is for butyric acid. Okay. All right, let's put stuff on board. So, you determine exact identity of your uncs. Using physical tests, okay. Initial info regarding functional group, qualitative chemical tests, specified functional group. Confirmation coming from IR and C13 and proton. Proton C13 can help you determine your carbon framework / connectivity. Just another word for it. And your either melting point or boiling point helps you confirm identity. You will get mass specs. Okay. There's a nice outline on page 455 of kind of how this whole process works. You guys may or may not have hopefully probably read. All right. More details. Today, the initial aqueous, AQ, solubility tests. Okay, do those just like they're described in the book. I do it twice today. Just get that out of the way, really confirm it. Okay, do one, do the next one, do another one, do the next one. Okay. For all the tests, there are standards. So if you're doing the 2,4 DMP test, right over in there, there is a ketone, okay, that you can do, and you should do so that you know what a positive test looks like. Okay. You could even do that for the solubility tests. Okay. If you come up, students love to come up and say, hey, is this a precipitate? Does this look right for a positive test for the iodoform test? I'll say, well, what did the standard look like? And half the time, nobody had the what? The standard. Go do it for the methyl ketone that's back there. I think it's acetophenone. Okay, and that'll tell you what it's supposed to look like roughly. Okay. All right. When you're doing the solubility test, make sure that you're using the right concentration of the solution that you're using. I forget actually off the top of my head right now what concentration of hydroxide you use, but I know that later we will have two different hydroxide solutions. One is for a qualitative test and one is for the aqueous test. Make sure you're using the right one. Okay. Another thing too is if you're following the flow chart. Okay, it's not soluble. It's not soluble in HCl. Now I'm trying sulfuric acid, concentrated sulfuric acid. Okay. If you get to that point, everybody Isaac, because people forget this all the time. If you're trying sulfuric acid, if you see a color change, if you see a precipitation, if you see any sort of reaction, heat giving off, a little bit of smoke, you count that as soluble. Even if it doesn't dissolve, and this is just for sulfuric acid, if you see a color change, any kind of indication of a reaction, you count that as soluble. Okay, does that make sense? And each week, you add on some qualitative tests. So next week is when we start doing the DMP test and the ionoform test and stuff like that. Today we're just doing the aqueous solubility, melting point if you want to do a melting point, the organic solubility, which is just basically, is it soluble in chloroform? That's all you need to find out. And you can do the Beilstein, which I'll talk about, and the ignition test, which I'll talk about. But each week we'll add on more tests. And again, just because I add on a test, don't feel obligated that you've got to do that test if there's no sort of indication from the aqueous solubility part that says you should do that test. Yeah, so qualitative tests, both main functional group and subsidiary functional groups. Will not conduct every main functional group test on every unknown. I said this 6 times now. Okay. The aqueous solubility test tells you if you should try a qualitative test. There are standards for each test. Do them. Do all subsidiary tests. Okay? Because of the rules of the game, right? Even if your unknown has one of those 7 functional groups, it could also have a subsidiary functional group, and it could have multiple subsidiary functional groups. Some UGs are stinkers. Okay. So keep cap on and in beaker. Okay. Wash pipettes and spatulas. Okay. All right. Okay, almost done here. I would like, by the way, I'll find where that YouTube video is that I made for running the IR. If you can all make sure that, take a look at that before we meet next, which is in 2 weeks, by the way. Next week. Okay. Today.
Okay, so yeah, it's a compressor and it seems that the bearing is
Preliminary classification.
Vibration wise, it's basically the noise
color, appearance,
It's, yeah, my spot like I said.
smell, make sure you waft. Okay. Melting